Alright, hello everyone. It's your friendly organic professor ready for another installment of Organic 1. Today I'm going to talk to you about nomenclature and also about drawing line angle, also known as skeletal structures. So let's get right into it. So here is the long version of the rules for organic nomenclature. I'll highlight here. We have it's the prefix, parent, suffix format. Today we're not even going to talk about the prefix. In fact, this is going to be very pared down. We're going to talk about finding the most important functional group, finding the longest chain, naming it in that way, and part of that is numbering the carbons on the chain. So these are the functional groups you're going to need to learn how to name as part of Org 1. You'll notice most of them have suffixes associated with them, and that's how we designate what the most important functional group of the molecule is. Today I'm only going to focus on 3 or 4. So the aldehyde, which has the al suffix, so something like butanal. The ketone has the -one suffix. Alcohols, which end in -al, and then just regular old vanilla alkanes. And the rest of these we'll save for another day, another time. So let's start with some alkanes and some cycloalkanes. Hopefully by now you've learned the general names for the alkanes: methane, ethane, propane, butane, and so on and so forth. So here we have a linear alkane and then a couple of cyclic alkanes. So there are two things I want to teach you while I'm on this slide. One of them is the line angle or skeletal form. And this is just a shorthand form that we chemists use so that we can draw organic structures very quickly. So let me turn heptane here into the line angle form. There you have it. All we're showing in this case are bonds because it's a hydrocarbon. Essentially what we're saying is every vertex at the end here and the 3 angles in the middle are all carbon atoms. And the line between them is the bond between the carbon atoms. Now we all know that carbons always make 4 bonds, so if you ever see a carbon such as this one with fewer than 4 bonds, you simply assume that those last 2 bonds are taken up by hydrogens. Sometimes, to be extra explicit, because it is hard to see these particularly at first, we'll put the terminal carbons in explicitly. 6, 7. So there are 2 ways of drawing heptane. And let me go ahead and write that out for you. So yeah, this one's 7 carbons, so it's heptane. Over on the right here, we have a cyclic molecule with 6 carbons. If it were a linear, we'd call it hexane. As a cyclic molecule, we call it cyclohexane. 5 carbons is pentane. If it's cyclic, it's cyclopentane. So that's very straightforward. If it's a ring, instead of linear, you just add the prefix cyclo. To draw this in line angle, you just make a hexagon for cyclohexane and a pentagon for cyclopentane. All right. Next, we have a couple of alcohols here. So you may recall the suffix for alcohol is -all. If there were no alcohol in this molecule, 6 carbons, so this would be hexanol. This one would also be hexanol, 6 linear carbons with 1 alcohol functional group. But I hope you're saying here now, wait a minute, these two atoms are not, or these two molecules are most definitely not the same. You're going to have different boiling points, different solubilities in water, that sort of thing. This one has the alcohol, the OH is part of the terminal carbon. Here, we're right in the middle of the molecule. So in this case, what we need to do is number our carbons. We number the carbons from one end of the chain or the other, and we start with the end closest to the alcohol. So this one, it's pretty straightforward. The alcohol is on the end, so that becomes the 1 carbon, 2, 3, 4, 5, 6. On this side, we have 2 choices. We could do 1, 2, 3, 4, 5, 6, or we could do 1, 2, 3, 4, 5, 6. Let me write that out. So with the red, I've numbered from the right, and I'll use green here to number from the left. So let's come back to this one. This one, all right, the alcohol is definitely on the 1 carbon, so we just designate that by putting in a prefix. So this is 1-hexanol. Sometimes it's called hexane 1-ol is another way of writing it. I like to put the prefix 1. I think the 1 is a prefix. I think it rolls off the tongue a little better. The one on the left here, well, our choice is either that the OH is on the 3 carbon or it's on the 4 carbon. And we choose the lowered number carbon. Again, this is the most important functional group. So we're going to, so this one is 3-hexanol. In fact, there is no such thing as 4-hexanol because, you know, you could always renumber the molecule. So that's one thing to be careful of. Make sure that you start from the end, the terminus, that'll give you the lowest number. Aldehydes have the suffix -al. So this one is pentanal or pentanaldehyde. And aldehydes, you don't have to say 1 pentanaldehyde, because the aldehyde functional group has to have an H and a carbonyl. Well, there's 3 bonds already, so it can only have 1 bond to a carbon, so it's got to be at the terminus of the chain. I didn't show it on the last molecule, but I'll go ahead and show it now, as if we want to change this into line angle structure. Something like that is all you need. You could also, ketones have a suffix -one. Here we could number 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. It's going to be better to number from the left, as we've drawn here. So this is going to be pentanone. And because the ketone is at the 2-carbon, it's 2-pentanone. And here is our line angle form. All right, now we got to combine two things. We have a cyclic alcohol. A little bit of trouble with my pen here. And a cyclic ketone. There they are in line angle. The nice thing about cyclic molecules, when there's just one functional group, because it's a ring, you know, there's no terminus, so you could say, all right, well, there's the 1-carbon, there's the 1-carbon. And yeah, you don't have to say 1-cyclohexanol, you just say cyclo, because it's a ring, hex, because there are 6 carbons, all. This one is, again, cyclopentanone. Okay. All right. Closing up here. This, now we have, I've drawn the molecules in line angle structure for you. So if you want, you can practice drawing them out in longhand form. What do we do when we have 2 alcohols? Well, we say diol or triol or tetraol, or for alcohols, dione, trione. So you just use that di, tri, tetra, penta, and so forth prefix. So this is cyclohexane diol. And we have to number the carbons now to differentiate, say, if the alcohol was here and here, or here and here. So this is 1, 3 hyphen cyclohexane diol. This one, 1, 2, 3, 4, 5 carbons. So this is 2, 3. Sorry, I should number these. Pentane dione. And here, 1, 2, 3, 4, 5, 6. And I chose left to right so that this alcohol, you know, we'd have 1, 2, 4 rather than, what would this be, 3, 5, 6. So we want the lowest numbers possible. So this is 6 carbons. So this is hexane, is the parent. The suffix is all, and there are 3 of them, so it's tri, all. And we just got to put in the 1, 2, 4. You'll note that the numbers are separated by commas, and the number word is separated by a hyphen. So, this is what I've taken you through today. We found the most important functional group for alcohols, ketones, and aldehydes. The longest chain. Well, this will make more sense once there's other stuff going on. Number the carbons on the chain, and then write the name as a word. Use di, tri, tetra. So the next thing is to start learning your other substituents. Sometimes the chains have branching, so methyl, ethyl, propyl. Go through all these. You have a handout with this on. You need to learn them. You also need to learn these other substituents like halogens. This will be a talk for another movie or another day in class. Thanks.